Now I'd like to talk about George Caryotakis. And George, I've got you on the phone. Can you hear me? Okay, good. Well, first I'm going to introduce you. You spent a couple of years at Varian, went to IMAC. We'll talk about that in a moment or two. Got your citizenship. I've got that slide up that I sent you. Ended up working at Varian, retiring from there. Didn't like retirement, came out of retirement in 1990 to join SLAC as sort of Mr. Claystron there, the Claystron microwave department. So I'm going to explain that originally we had the Stanford Linear Collider, which was the 100 billion electron volt device. There was a dream then, which has been referred to a little bit earlier, about a new big science experiment, and George is the one who came in to work on that. And so George, I'm going to play your video and then we'll have a little discussion here. Sound good? Okay, let's see if I can get it going here.
Can I say a couple of things about it?
Go ahead, George, while I bring up the video.
The video was inspired by the simulation that we did for the Claystron that Richter wanted for the so-called next linear collider, which was well beyond the state of the art. So we did some simulations, and the shape of the beam at various degrees of drive or saturation seemed to call for a movie. So I had a movie made at Stanford with some accompaniment, musical accompaniment showing how.
Okay, we're going to look at the movie now. Hang on.
There you go.
Well, we're not getting the video. Audio's all the way up. Well, as usual, it works well at home, but it's not working here. But this is the view of the current linear accelerator we're looking at here. And we showed on the slide some of the specifications. George, you want to talk a little bit about that NLC program?
Well, the NLC program was supposed to be a natural extension of the collider that was working at SLAC, modified from the original one way. They managed to create positrons and collide them, and that was in full. That was working when I was hired, and I was hired to come up with a Claystron design that would be suitable for a collider that would be roughly 10 times the power, the energy of the existing collider, and about 15 miles or 14 miles in length compared to 2 miles. And that Claystron did not exist, needed to be developed. So when I arrived at SLAC in 1960, I was out of a job. I retired from Varian, and I was getting bored, but I answered an ad looking for somebody to run the Claystron department, so I got the job and hired a number of people, hired a sizable team to work on this tube. And eventually we got one to work at 65 megawatts and X-band. Not only that, but it had to be periodically magnetic focused, which means not a huge magnet, but a magnet with reversing polarity, so that it would be much smaller in size. So it was quite a taking, but it did work. But by the time it worked, SLAC essentially lost the contract, international contract for the so-called. It wasn't the next linear collider. It was the
So tell me about the move to X-band. What made you go from S-band, the 10 centimeter band, to the 2.5 centimeter band?
Well, it was a matter of making the thing shorter. It was already long enough at 15 kilometers, 15 miles. An X-band, things shrink. And the problem becomes that you have to design sources that have to produce that power in smaller dimensions of cluster cavities and so on. So the problem was designing the clusters without which the linear machine wouldn't work.
So George, tell me, you told me a little bit earlier that out of Stanford, you had a project at IMAC that kind of set you going. It was kind of your launch. Tell me a little bit about that.
Okay, I went to work at Varian with a degree out of Stanford, and after 3 years or 4 years at Varian, in 1960, I was hired by IMAC, which at the time was trying to get in the klystron business at higher frequencies than I had previously been by using external cavities, which allowed tuning and coupling to be variable outside the vacuum. But they wanted to get to S-band and X-band, and that required integral cavities, so I worked on integral cavities in a new laboratory they set up at Belmont. I hired a number of people, many of them out of Stanford. And at one point we responded to an RFQ, a request for proposal from the Air Force at Rome, New York, who at the time thought they had a need for 1 megawatt CW at 8 gigahertz. So they put out an RFQ. Varian apparently responded with the assertion that this couldn't be done. We said it could, and we got $1 million contract to build this tube. It was the contract was based on first being able to run a beam down the klystron with 99% transmission, because if it didn't get the beam from one end of the klystron to the other, you couldn't get any RF out of it. Maybe I'm talking too much, but anyway.
Well, tell us what it was called colloquially.
Colloquially, it was called 1 megawatt CW X-band klystron. The frequency was 8 gigahertz.
This is the one that they called the death ray.
I don't know what the Air Force had in mind in spending the couple $1 million they eventually spent on this development, which sounds like small change today, but it was a lot of money then. And it was some kind of an attempt to intercept a missile, or at least to knock out its electronics as it was coming at you. So they thought they needed something of that order, and they got it. Mm-hmm. And by the time they got it, the need disappeared, so nothing happened. They was put on display at Rome for a while, I think.
So tell us a little about the 90s there at SLAC. What was that like working there, and what kind of
SLAC,
group did you have?
In the 90s, having essentially the task or being told to develop this tube that didn't exist, it was very exciting. Once again, I had to hire quite a number of people because the personnel in klystron experience was essentially non-existing. Mm-hmm. So we had a good group assembled at that building, which was the first building put up on the SLAC campus. The whole thing started with a so-called Project M. M stood for Monster, which was the Monster Accelerator. And I even worked on the first klystrons out of IMAC because initially SLAC put out
that was some
Final
good
two
project
work.
days then, George. Thanks for your time. We're going to wrap up here, but I'll be touching base with you next week again.
Very good.